All right, okay, here we go. So let's jump into Atom. All right, so raise.js. And okay, so first one I want to work through is reduce. Well, okay, something I want to touch on as well is as you're working through these JavaScript problems, if you can, try to solve them without using the built-in array prototype methods. So right here in each, I could solve it this way, or I could go elements dot for each, and then I could pass in item, and then I can go.
Ben, stop, Ben.
Uh-huh.
I can't see your screen.
Oh, you can't see my screen. Oh, oops. Oh, there we go. All right. Let me delete that.
Thank you, Ben.
All right. Thanks, David. Okay. So here we have our each function that starts on line 6. So to reiterate what I said, if possible, I would like you to write these functions without using the array prototype methods. But anyway, go back and refactor them once you finish. So if you're able to, if you write them with the array prototype methods, then jump back and you can refactor this once the project's done, once you have everything else finished. So so I'll show you both ways that you could solve each. So using the array prototype method, you could go arrays dot for each, and then you could pass it an arrow function, and then parentheses after that you can go callback, and then pass in the item like that. So this is the very shorthand syntax using arrow functions. Yeah, so it's we're passing in a single callback function. This will accomplish the same thing that this does. But for the rest of my examples, for the most part, I'll kind of switch back and forth. But so right in here, I'm just going for let I get 0, I less than elements dot length. I'm just iterating over the elements array, starting at the beginning, and then I pass each value as well as the index into the callback function. All right, so that's all that's required for each. So it's pretty simple. You don't even have to return anything from the each method. Okay, so the next one that I get a lot of questions about is reduce. So part of it was I need to improve these instructions a little bit. I know that caused some confusion, but the way that I solved this was the reduce function. The first argument that comes in is this elements array, and so we then actually reuse each that I wrote up above, const each up there. And so I pass in the elements array, and I pass in a callback function that will then feed all of the elements into it. And if I wanted, I could rewrite this just in a for loop. But the key thing that's happening here is with this memo. So memo is a starting point that the reduce method can build off of. And it can be defined. It's an optional parameter, so it may be defined or it may be nothing. And so the way that a clean way to be able to solve this one is that when you pass in, you can set memo, the default parameter, to elements.shift. And so what this does is .shift will take the first item off of the front of the elements array, and it will make elements a little bit shorter, and it will set that to be the memo. So that's like your starting value. And then down here, as we're iterating over the elements array, memo is going to be overwritten at every single iteration of the loop. So we'll say memo is equal to the result of the callback function, and then we pass in memo, and then the new item. So this can be a little confusing if you don't understand what reduce is supposed to do. As you're working through these problems, the first step you should do is figure out what is this function supposed to be doing. The next thing that you should be comfortable with is figuring out this idea behind a callback function. So let me jump into JSBin real quick. All right, so let's play around with reduce real quick. So if I go const nums, so that equals to 1, 2, 3, 4, 5, and then I can go nums dot reduce, and then inside of here I can pass in I pass in my callback function. So I'll do my arrow function like that. Nums will give me the memo plus the next number, and then what I can do is I can go return memo plus num. So memo, or sometimes you see it called like ACC for like the accumulator. It's the running total. So you think of it as like it's the running total, and so I'll assign that result right there. And let's go console.log result. We'll print it out, and you see the number 15 gets printed out. And so, well, let's do this. Let's go console.log memo no. So on this, you see 1 and 2, and then 3 and 3, and then 6 and 4, 10 and 5, and 15. So the first time it runs, memo is actually the first number of the array, and then the num, the first num that it's passing in, is the second item of the array. So it's reduce it's a function that feeds you in your items one by one, and then allows you to reduce it down to a single item. And it doesn't have to be with numbers. The same algorithm and the way that I've set it up could work with strings as well. And there's any number of different ways that we could apply this and we could use it. So you can see here that it gradually builds it and connects it all together and returns the string hello. Okay. All right. So that's so again, just to review, I've had a lot of questions about this. A callback function it's a function that you pass to another function. Functions in JavaScript behave just like any other value. Just like strings or objects or numbers or whatever it is that you have, you can put functions inside of arrays. You can put them on objects. You can pass them as arguments into functions. You can return them from functions. So they anyway, you can pass it. You have a lot of flexibility with what you can do with functions in JavaScript. All right, so let's come back to Adam. All right. Let's look at filter. So, well, all right, let's look at find actually. So I know some people had some confusion about this idea of like passing a truth test. So with find, the purpose of find is that they're going to give us an array of anything, and again, we're not concerned with what's in the array. It could be numbers or strings or objects, we don't care, but they're going to give us an array, and then they're giving us a function that they've written, and we don't care what the function does or what what they've written in the function. We just care that we have a function, and then we are trusting that they are going to return either true or false when we invoke the callback function or the function that they gave us. So again, we're just iterating over the array. We pass each item from the array. We use this bracket I to dynamically access the item that's in elements at each cycle of the loop, and we pass that into the callback function. And so we're expecting the callback function to return either true or false. And so if it returns true, then we're going to run return and then the item at that index, because find just wants the first item that returns true from the function they gave. And the use case could be maybe there's a million objects inside of this array. Probably not that many, but there's just a ton in there, and they want to find the first, they want to find the first object inside of that array that has, a special parameter. And so in their callback function, they're going to check to see, if each object that we pass in has that parameter. And then if it does, it will return true, and then we will give them that item. So again, it's like we're reinventing the wheel. We're kind of building some shortcut functions that already exist, that have already been written, but we're rewriting them, reinventing the wheel, so that way you can get some practice, specifically a lot of good practice with iterating over arrays. You're doing that all the time. Pretty much every time you write a for loop, it's because you're going over an array. And you're doing that all the time, and then and also to give you practice manipulating element or items that are inside of arrays, and then manipulating properties on objects. Okay, feel free to chime in with questions at any time. Just pop them up in Slack, or I just. Now I have it up so I can see it, or feel free to chime in and ask questions. Okay. All right, flatten. So I know this is one that people had a lot of questions with, and I'm going to walk through this one line by line because it's a good example of recursion, and it highlights a couple different uses for some different array methods. But first, I want everyone to go into Socrative. I want you to go to socrative.com. I'll post the link again. Go to the classroom, or go to student, and then go to the room Lambda School, like that. It will automatically make it. A uppercase. But then if you come and join in there, I'm gonna have some different questions. I'm gonna pull you guys on. So A, B, C, D, E, with find, what we just went over, put A if you feel pretty confident with what I just talked about. Put E if it just went over my head, I'm zoned out, I'm totally lost. So, and then just in between, B, C, D, E, we're all in between. It's totally anonymous. No one else can see your answer. I'm the only one that can see it, and I don't even know who's. It's all anonymous to me too. I don't know, what you're entering, who's entering what. Okay. All right. Let's do another one. Let's do this for the reduce function. So A if you got it, E if you're totally lost on it. Okay, all right. Okay. All right, so now we are going on to flatten. So if you would like, you can take and you can spend your time, if you want during this, we're getting beyond what you've looked into, if you're interested, you can go and just, keep working on the project. I'll say that for at least this one, but I'm going to go and walk through flatten, and we're going to go over specifically recursion, and hopefully this can, clear up some stuff. So, all right. So let's clear this out, and then let's go. All right. So const result is equal to flatten. And then let's go 1, 2, and then 3, 4, 5. Then, yeah, I think those all closed up automatically. All right. Oh, reduce is not defined. Because I'm doing this right here. Let's do. I wrote this reusing the reduce function, so let me just do that. Okay, great. All right. So, okay, so here is a recursive function. So there's, kind of two ways that you can write a recursive function. One is that you can make the whole function recursive. The next one is that you can make that, like you can have a subroutine. You can have a function inside of that function that you iterate on or that you call recursively. And so, some advantages to doing it different ways. But let's so we'll walk through this. I'll walk you through it line by line. So, all right. So as we start going down through everything, const flatten is defined in scope. Then we come down here, and then const result is defined. Flatten has a function assigned to it. Result has this expression assigned to it. So the computer doesn't know what value result has yet. It has to go in and call function with this argument. It has to figure out what this is. It doesn't know what this is yet because this is it hasn't been simplified yet. It hasn't run, and so it has to take. So it's going to take this array, pass it into the function, invoke it, and then we're going to come up here. So elements is this. So that array is the elements array. So we come down to this line, and then we have this flattened array. And so flattened array, we're saying flattened array is equal to this big long this big long expression right here. So in order for it to know what flattened array is, in order for it to know what's going on here, it has to sorry, lost my train of thought. Oh yeah, and real quick, this is an example of not using a subroutine. Sorry, I mixed up. I was thinking of a different function that I had wrote. But if that didn't mean anything to you, don't worry about it. Okay. So our array is going to be assigned, or this variable is going to receive the value of whatever this expression returns. So now it has to evaluate this expression. So we start from left to right. Elements is equal to elements, which is equal to this array. So we're saying that array dot reduce. Okay, so we're reducing it. We're trying to reduce it down to a single value. The second argument that we pass in is a callback function. The third argument that we pass in is an empty array. So this empty array is the starting point. This is what memo will be initially. Memo is going to start out as an empty array. Okay, so now this callback function is going to be invoked on the first value in elements, which is a 1. So we now come in, so we have memo, which is an empty array. We have item, which is 1. Now we come down, if array.isArray item. So we're going to check to see if this item is an array. Because if it's an array, then we want to call flatten again. And we want to feed that array back in. But this is not an array because item is 1. I'll just kind of put some notes here to keep track. So item is 1. So it's not an array, so this is false, so it skips that line. Then it goes return memo.concat item. So concat. Let's look at concat real quick. So if I have const nums is equal to this, and I go nums.concat, and I go 1, and then I go console.log nums. What it's going to do is, let's see, right. So if I do, actually it's, sorry, it returns a, sorry, it doesn't mutate it. This is it doesn't, it does not mutate the original array. Okay. That's why we use it in React. when we change arrays on state. But all right, so you can see here that it took 1 and it added it into the array. If we already had a 1 and 2 and a 3 in here, then let's say that we had an array of 4, 5, 6, what concat will do is it will add the two arrays together into a single array and it returns a copy. It does not mutate the original, but it returns a copy with both of them added together. So that is what concat does. It adds two arrays together, or if it just receives a value, it just adds it into the array. It's like a push. It essentially just pushes it on the end if it's not an array. Okay. So, all right, so again, to come back up here, this function is running. So you have elements, which is this array. We go dot reduce, pass it the callback function. We pass it this empty array. So right now, memo is equal to an empty array. Item is equal to 1. So 1 does not pass this test, so we come down here, return memo.concat item. So memo is empty, we do a concat item, and then the callback function finishes, and now it executes again, and it passes in the next item in the array. So at this point, memo is now 1, item is now 2. Comes down, 2 does not pass this, we do return memo.concat item, and then this callback function is invoked again. We have 1, 2. Now the next item is array 3. Okay, so we come down here, array.isArray item, true. So then we hit this return, and then we go memo.concat, and then we do flatten item. So again, item is this, and we do flat. So concat, in order for this to return, this has to finish resolving. It has to resolve down to a basic value that it can return. And so because we're calling flatten again, this function is going to hang open for a while until this is all done resolving. So I'm going to copy and paste this function down below so you can kind of see a second example. So this is what this is like a second flattened that is opened right here. It's like another flattened was opened. And so with item coming in, and so elements is this item, which is 3. Okay, so we come down here, we have elements dot reduce, so we have 3, and essentially what it comes down to is inside of here we have we'll have an empty array, and then we will have the string 3, and then we're going to go if array.isArray item, it's not because it's just a 3, and so then we come down here, return memo.concat item, so it adds 3 into the array. So flattened array finishes, flattened array is it's array 3. So, and the reason we do this recursively is because we don't know if that array, it may seem overkill right here because we could just immediately concatenate it, but we don't know if there's other arrays nested inside of it. So we hit here, return flatten array. This all returns and closes. Flatten item right here returns, and it gives us 3, which we then concatenate to memo. Memo then finishes this callback function, goes back up to the top, and starts running through it again. And now we have 3. So item is, at this point in time, item is now 4. It's going to come down, it passes the array test. It's going to open up flatten again. So inside of the flatten array, it's inside of this this flatten method, elements that comes in is going to be just an array with 4 in it. It's going to come down. It's going to run this loop with an empty array, and then with the number 4, return memo.concat item. This right here is going to be an array of 4 that's returned. This function finishes up and closes. Flatten array item is now 4. 4 gets concatenated onto this. So now, as this callback function finishes up right here, we are now at 1, 2, 3, 4, and this thing right here. Okay. So now it's as we hit array.isArrayItem, that's yes, and then it's going to go flatten item, and it's going to pass this item in, open up another function, and then as this comes in, memo will be empty array, and then this is going to have one layer of arrayness taken off of it, and then we come down here, array.isArrayItem will be, that'll be true. It's going to open up flatten again, come down, memo again, another layer is taken off, comes down, its item is still an array, so it's going to open up flatten again. So you see that we have all these different flatten functions getting opened up. And so at this point in time, all these other ones up above it are waiting for something to return from that call. And you can see how if you weren't careful, you could get in a situation where you have 1,000 functions that open up and none of them are ever returning and it's never stopping. And this is why they say maximum call stack size exceeded. Because this is like, these functions are kind of like a stack of pancakes if you think about it. This one's on the bottom, and then we put another one on top, and then another one on top, another one on top, another, and keep adding. And in order to resolve it, we have to take the pancake off the top and then take another one off the top until there's no pancakes left. So it's like they stack and build on top of each other. All right, so then we'll come down in here. Another layer is taken off, and then it's still inside of an array, so it's going to call it even again. So then now we get to 5. So now it's going to come down here, return memo.concat_item. So this will bubble up, and it will return a 5 to there, which will get returned up to here, which will get returned up to here because they have nothing, those ones have nothing else to iterate over. That'll get returned up to here, and then up to here. And so flatten item here becomes array 5, memo.concat5, and then it now finishes, and flattened array is now 1, 2, 3, 4, 5, because it's all been concatenated together, and all these functions have now closed up. And then we are left with this nice, tidy little array. So that is the adventure that this code goes on when we invoke it. Run it again, boom. So that's what it went and did. It went and dug down and did all that crazy work and opened up all those different copies of this flatten function in order to bubble up a value that has it flattened. The cool thing about this function is that regardless of how nested things are, it will always return a flattened array no matter how deep it goes. All right. Does reduce ever get to the point that an object array is so deep that it gives max stack size error? Yeah, usually there's a limit. I think in Chrome they limit it to, I think it's, I don't know. I don't know. I'll have to look it up. I could be totally wrong, so I'm not even going to guess. But yeah, so there is a limit to it, and so you could have an answer so big and it could be so nested that it could cause some issues. So, for example, if I did so I'm just going to do tons of arrays, put a 10 in there. All right, let's see what happens. Okay, so that still did it. This still goes pretty fast. With some recursive solutions, depending on depending on their complexity analysis, and we'll go into that later, it can. Anyway, specifically, there's a rock paper scissors problem we're going to have you do that. The way that it scales it, if you start making it really big, it will actually you can actually crash your Chrome browser with JavaScript code because it takes so long to run. And the recursive function is having to do so much and opening up so many different function calls that it really takes like you're getting it down to where some of the stuff we might be working on in the course, you'll be trying to make it so your function, instead of 10 seconds to run, seeing how fast you can get it to run. So anyway, I hope this helped people kind of, yeah, crash without JS code, yep. So I hope that this helped people to grasp JavaScript, or grasp recursion a little better by walking through it line by line. It can be a little tricky. It can be a little hard to work through it, but anyway, hopefully this helps. Hopefully having a recorded example of me walking through recursion slowly, hopefully that will be a big benefit for all of you. So, all right, so now let's jump back in and go over a few more problems. All right, so let's look in objects.js now. Okay, so this first one, you can just go object.keys, pass in the object. So again, object with an uppercase O, that's the global JavaScript object. It's the constructor that's used behind the scenes when you make a new object. So whenever you go like const x gets like that, whenever you do that, behind the scenes it's essentially going new object. And you can use this code to create a new object, but don't. Just use this. This is best practice in JavaScript. Just use that shorthand syntax. So, but because of this, sorry, let's switch to that. So this object right here has a bunch of different little helper methods and things that are chained on it. It also has the prototype, so it has all the methods that all of the objects inherit. So anyway, it has this nice keys method on it. You pass it in an object, and it returns an array of all the keys as strings. On an object, all the keys are always strings. If you put like a number on an object, so I mean, if we did object 1 gets 10 or something like that, the 1 will actually be turned into a string if we were to examine the object. So all right, so object.keys object. All right, so let's look at values now. So this is the preferable way to iterate over object keys. The other way that you've seen is for let key in object. So you've seen that. That's frowned upon for some different reasons. It can be inconsistent with the types of properties that it loops over, but or just like with the way that the object's set up, it's hard to keep that consistent and totally secure. So by secure, I mean like your code not getting crazy bugs and falling apart, not like hackers secure. So we have object.keys, and again, this is an example of method chaining. We chain all these different methods onto each other. It's read from left to right. So we see the object, we grab the object, and as a keys method which we invoke, we pass in this object. This will now resolve to an array of keys. Now arrays, they have the map property on them. And so because this right here resolves to an array and returns an array, we can then chain a .map on it. So then it will read .map on the array of keys. And then that passes in a key. And so map returns an array. And so then we can just go return object key like this. So if I were to run this right now, the linter would bark at me because it would want this to be a like that shortcut arrow syntax. I broke this down, hoping that it would be a little bit easier for you guys to read while I show it to you. I've changed that rule actually for the next assignment. That's one of the things that I've made a little looser. Okay, so this will return the value with the map, and so this whole phrase will return an array of all the values from the object, and so that will pass. All right, the rest of these, that's from me showing an example to some people earlier. Let's go over defaults. So object.keys, we have this default props object that we pass in. That returns an array of strings. And then we do the for each on it. So it's the exact same thing that we did up above. This is that phrase that we're going to use, or that that line we're going to use to iterate over objects. We do it here, we have it here, we do it right we do it right here. So anyway, it's pretty common. You're doing it in every single problem in here. You're iterating, or you're doing object.keys. So, all right. So we have object.keys, default props, dot for each key. Okay, so it's passing in the key so we're getting all the keys on props. That's what this line is saying, is give us all the keys on props, or all the keys on default props. So then what we do is we check to see if the object has that key on it, and I'm going to save this for another day. I'm going to save this this discussion for another time, I think. No, I'll just go right now. Okay. All right. So accessing has own property directly on the object can lead to some. It's frowned upon because has own property could potentially be overwritten as a property. So like these property methods, it's very easy to accidentally overwrite them, and that can be so the linter will catch it. And so has own property, you actually want to, or some of those other native object prototype properties, you don't want to invoke them directly on the object. You want to do this big long thing. So you go object, global object, dot prototype, dot has own property. So that's where this has own property method lives. So we're saying has own property, but has own property was originally written to run, like this, object dot has own property. So it was meant to be chained off of an object, the object that we want to call it on. Well, here we're accessing it directly on the prototype, and so where you have to use dot call, so we can pass in obj to specifically set the this context within the has own property method. Clear as mud, right? Okay. So we're saying set the this key because has own property behind the scenes is using the this keyword. So we're saying this object is what we want the this keyword to refer to inside of the has own property function. And then here's the key that we're passing in. So we want to check to see if this key exists on that object. And if you were able to work through this.js and work through .call, .apply, .bind, then this will make more sense to you. So this is just saying, this is a big long way of saying, does object have this key on it? Can I repeat that? This part again? I will dive into this. I'll go into this.js in just a minute. So just right now, just remember this is how you check to see if this key is on this object. And so this will return true if it is, false if it isn't. And then, so we just iterate through. We find all the keys that aren't on the object by default, and then we add them. Okay. All right. So we will. All right. So let's move on from objects.js, and then now let's go look at this closure one real quick. All right. So we'll go over an example or two in here. Let's see. Yeah, I'd have to look into that. I'd have to look into that. Yeah, that's the convention. That other way is the way that I've typically done. I'll have to look at the in keyword and see. I know that. Well, yeah, I'll have to look into that a little bit more. I'll let you know. All right, so with const counter, for example, we have this count variable that we initialize to 0. So we have let count get 0, and then we return a function. And so this function, when it's invoked, it'll be like down here. We'll go, const new counter gets counter, and then as we invoke new counter, it will return 1, 2, 3. So it's interesting because we're not changing any arguments or anything that we pass into new counter, but each time we invoke this function, it's going to return something different. And so that's the idea behind closure scope. It's this count variables behind the scenes. We invoke this function, and then we get that value back. So the main advantage to this is that we have no direct way of accessing count, and you can want that. That can be a desired behavior that you don't want it. So that way, out here where new counter is being used, that the coder here can somehow accidentally mutate and modify this count variable. Okay. All right, let's look at counterfactory. So in here, we define let count gets 0. And then in here in the return, we're returning just an object. So this right here is just an object. It has 2 methods on it. So increment is this arrow function, and it returns plus plus count. And then decrement returns minus minus count. So you might be wondering, why is the plus plus before count instead of after it? It's because when it comes after, what happens is count would get returned, and then it would be incremented. So the first time we would run increment, it would return 0, and then it would increment it to 1 behind the scenes. And the next time we run increment, it would return 1, but then count would actually be 2 behind the scenes. So if we do plus plus and minus minus before the variable, then it will increment the variable, then return it. So again, this is pretty cool because we can invoke these, so if I go, const counter gets counter factory like that, then I could go counter dot increment, and this obviously wouldn't work in this scope because I'd be rewriting counter up here. The constants would conflict. But if I run counter dot increment, like that. So right now the test is actually it's actually testing for it to go negative, and that's something that I could have mentioned in here as well. But so it actually is checking for a negative result. So so counter dot increment, what that's doing is that's going in and increments this count variable behind the scenes. Okay, it is looking for a negative number, a negative result. Okay. All right. So that's the idea behind closure, is that you can have these variables, properties, or these you can have these values that are kind of in this secret little private storage spot that are not available to the outside, but then this function can still reach back in and access it, and it has private access. So it's a way of kind of fandangling private properties on objects with JavaScript. So all right, so cache is the same from the JavaScript mini bootcamp. Let's see. All right, I think I'm going to. All right, let's go look at this.js. I'm not going to go over the ES6.js just because I've been talking about a lot of ES6 stuff as I go through these other files, and then I've also helped a lot of people with the ES6.js file. So so I'm just going to come in here. So all right, so in this.js, it's just kind of covering some basic examples for how this works. So this keyword works. So right here, we are creating a new user, a new instance of this user class. And so, yeah, so we come up here. All right, okay, sorry, I was scrolled down partway through the page. Okay, so here we have class user. On the constructor, we have this.username is options.username, this.password is options.password, and then we have check password. And inside of check password, it's going return this.password triple equals password to compare. Okay, so the reason we have this is because with user's like a kind of like a template, or it's this little factory thing that is building new users. It's building new little user objects that we can go and use elsewhere in our code base. So we could use this user constructor to make 10 million other little user objects, and they would all have a similar pattern, a similar structure to them. They would all have this check password method on their prototype. They would all have these a username and a password property set, but they would be unique. So if we have all these millions of user objects all using this exact same function, this same code, we need to write this function in a way that allows it to dynamically represent whatever object is trying to use it. So right here we have this .password. So when we come down here, so we've created a new me object and username lambda school, password correct horse battery stable. All right. So down here we have const result. We set this equal to me.checkPassword. So when we run check password on me, it's going to come up here. It's going to run this function, and it's going to come down in. It's going to say return this. Okay, so it wants to know what this is. So if you ever want to know what this is in a function at the time that it's running, the main rule that works most of the time is look where the dot is. So look at the function where it's being invoked, and then look to the left of the dot. So like look to the left of the dot. That's most of the time that is the rule for how you determine what this is. So we look here, and me, the me user object is what this will refer to. So it's like this is like it's saying me.password. If it was if we had a const another guy gets new user, username is ASDF, password is 123, and then we did another guy dot check password like that. Then when this check password runs again on this other object, we're going to come up, look at this code, and then we see the this keyword inside of check password. The this keyword, again, if we want to know what this password refers to, or what this refers to, we go back to where it's being run, and we look to the left of the dot, another guy. So this object is what this refers to on line 14 in that instance. So it's dynamic. It can change depending on which object is invoking this function. So that's why we have this. That's what it's used for, is it allows us to dynamically access, or it allows us to make a reusable function that many different objects can reuse. All right, so now we're going to rewrite that check password function, and it's no longer attached to the class. So we have check password right here. We're writing it exactly the same. The only difference is that it's no longer on the class. So that means that me can't access it as .checkPassword. So what we'll do is we have a couple different ways of calling a function and setting what this should be. Because right now checkPassword, it's not a method. It's not chained off of a class. It's not chained off of a function. So like if I came up and I'll just comment this out to avoid confusion. So this right now isn't going to work. So with check password, if I want to be able to use it with an object, then the way that works is I go check password, and I can go .call. Then the first argument that I pass in is the object that I want this to refer to. So I pass in me, and so that sets it. It says in this function, this is now going to refer to the me object. So it sets it to me, and then this string is the password, that first argument that gets passed in. So this right here will now correspond to this. So when you go .call, the first argument is an object that comes in and sets what the this context is. The second argument is going to be the first argument to this function. If we were going to pass in x, y, z to it, then we would just pass them in 1, 2, 3 right after. You just pass them in comma separated, and that's how they get fed into the function. So again, the important thing is that me sets the this context. All right, so if we come down here, we have .apply. .apply does the exact same thing. So me sets the this context, and then but instead the difference is that to pass in arguments, you use an array. So here we do call me correct source battery staple, then we can go like comma x, comma y, comma z. And here we have me and then an array, and that's it. It's only 2 arguments. But then inside of the array, we can go x, y, z, for up here. X, y, z. Okay, so it's just, we use an array here, we pass them all in comma separated here. That's the difference. Okay, so now if we come down to bind, bind is the last one. So call, apply, and bind. Those 3 are all kind of in the same family, do similar things. So, but what bind does, you call it on the function. These are all on the function prototype. So quick little side note, everything in JavaScript pretty much is an object. So arrays are built using objects. Objects are objects, of course. Strings are objects, and even a number is an object, and functions are objects. They're all built using objects at a lower level. So kind of crazy. If that makes your brain explode, don't worry about it. So what bind does is it takes the function and it returns a copy of it that has the this yep. So yeah, so check password. So okay, so .bind on the function returns a copy of the function where the this context is permanently set to whatever object you pass in. So right now I'm passing in me. So this would be set to me. And so this function right here, it makes a copy of it and assigns it right here. So bound password check will forever have its this context set to me. All right? The me object. And so then when we call it, we just pass in correct source battery staple, and then that's this first argument that comes in, and then we can run our comparison. Or we go 1, 2, 3 to pass in the arguments like that. So those are the 3 ways to set, to explicitly set what this is inside of a function. The other way is from inside of an object. Arrow functions do not have a this keyword. If you these even though we're using ES6 here, so if you notice, I'm using the function keyword. We have to use the function keyword here. Otherwise, this will just be a reference to the global scope. It'll be this global scopes this. So this is the one time when you're going to use the function keyword instead of an arrow function. And this is good because then it makes it very clear that you can see, okay, this is a function that's going to be interacting with this keyword. Okay. All right. So there's this. I'm not going to touch on recursion for right now. This is from an example that I was doing with a full-time class earlier. I walked through that one recursive problem in arrays.js. In here, again, it's so check matching leads is actually very, very similar to flatten, but instead of it returning instead of it like with a potentially unlimited nesting in an array, it's an object that could have unlimited nesting. And so check matching leads is actually a question that, again, like I mentioned this earlier, the question that I was asked when I worked for iFit. This was the job they asked me at the interview. I had to code this in front of like 4 or 5 other software engineers, all on a video call. And yeah, so these are the types of questions that, the types of functions that I want you to be comfortable writing by the end of the class. I know right now it's pretty hard, but or if you didn't even get anywhere close to even touching the recursion file, that's fine. We're going to work with you over the next 13 weeks to help you reach the level where these types of things are, they'll still be challenging. They'll always still be a little challenging, but at least getting it to where you're not stumped, you're not stuck, you're not just going in circles. All right, so yeah, that's it for this project. Covered some of the solutions. This will be a great project for you to continue to come back to as we move through the course, and I would encourage you to do so. We're trying to start out at a high level. We're just trying to move fast because in 13 weeks we need to teach you a lot of information and get you as deep into this stuff as possible. So again, reach out to me, reach out to Austin if you have any questions. The worst thing you can do is be silent. So please speak up and and let us know. All right. Thanks everyone. Tomorrow we'll go over data structures. Okay. All right. Have a good night.